A triangle. You know this already. A triangle is how many sided polygon? 3. And it has different classifications. Sometimes you can name it according to the sides, and sometimes you can name it according to the angles. So the sides in this triangle, there are 3 of them. There's side AB, and I want you to notice all the notations. AB is capital letters with the second bar on top. What's another side on this triangle?
AC.
And what's the third one?
BC.
All right, is it okay if you said CB instead?
Yeah.
Yes, that's okay. All right, now there's vertices. Vertices are points, just the little dot. So how many vertices do you have here? 3. So look, I'm only using a capital letter and no other symbol. That's a point. A, point B, and point C. An angle is not a vertex. An angle is different. An angle is the space from this side to that side. That's angle B. So we mark it as, this is an angle, and this is an angle. So we mark it as angle A. You have to know the difference. A is the vertex, the point. Angle A is the open space between, or the degrees between the 2 sides. We also have angle B, and we also have angle C. Throughout this, and then you have this word called opposite. So if we have side AB, write that down, side AB is opposite, meaning directly across, not touching, exactly opposite from what angle? C. Okay, those are going to be important words that you're going to need to know for this chapter. Say that again. AC is opposite from B. That's right. Okay, now it can go backwards. You can have angle A, this angle right here, is directly opposite which side? BC. Okay, so in a triangle, if you're looking for what's opposite, a point is going to be opposite from a side. There's not going to be 2 sides that are opposite or 2 angles that are opposite of each other. All right, hopefully the rest of this is review for you. Is anyone still writing? Hopefully this is review for you that if you have if you have all acute angles, that is an acute triangle. 3 acute angles. Some of you, I heard words for some of these other ones too.
Awesome.
Yeah, that's not going to be for angles though. That's going to be one name that we're going to use for sides. So this one is when we're looking at the types of angles. What do you notice right here? It's an obtuse angle. It's bigger than 90 right here. So if you have one obtuse angle, then it's an obtuse triangle. Exactly one obtuse angle. You can't have more than one. What kind of triangle is this one? Right triangle. Good. That's based on the angles. Exactly one right angle. All right, by sides. If you're looking at sides only, let me point out to you. No, before we say the names, let me tell you what's happening in this picture. This picture has no congruent sides, no matching sides. They're all 3 are different from each other. Don't say the word out yet. We're going to do that next. This one has how many matching sides? 2. Well, let me say congruent instead of matching. 2 congruent sides. And the last one has how many congruent sides? 3 congruent sides. All right, so now tell me the names. I kept hearing the word isosceles. Which one is that?
A.
That's the middle one.
The middle one is isosceles. ISOSCELES. C-E-L-E-S. But the thing is, it doesn't have to have exactly two sides. It has to have at least two sides congruent. So some of these can be named more than one way. At least three. That's parentheses. At least three. At least two. Sorry, I'm talking. Can't talk and write at the same time. It could have three. So that means two or more. At least two sides congruent. Yes, that is my purpose. What do you call the one that with no sides are congruent? Scalene. S-C-A-L-E-N-E. Triangle and triangle. And this last one? Equilateral. That's E-Q-U-I-L-A-T-E-R-A-L. That's when you're talking about sides, equilateral triangle. But every single equilateral triangle will also have equal angles as well. So just make a start here, but this is equiangular. Angular for the angles, lateral for the sides. Okay, are those familiar to you? You've heard those words before, right?
No.
Alright, so let's just look at how it's going to look for our kind of problems. Down at the bottom of that page. Anyone still writing? Okay, and please notice that a triangle like this has several names. It's equilateral, it's equiangular, but this kind of triangle is also isosceles. It has two sides equal to each other. It's like all isosceles triangles will be equilateral, but not all all equilateral triangles will be isosceles, but not all isosceles triangles will be equilateral. Okay, it's like it's a subcategory. So there's several different names when you have one like this. All right, so look down at the bottom. It says they want us to use the words for angle measures. So I'm going to highlight for you triangle A, B, D. Do you notice all three acute angles, or do you notice a right angle, or do you notice an obtuse angle? What do you notice in that one? In the blue one? Look at A, B, D. Obtuse. You see that 100 degrees?
Yeah, that's good.
Yep. So that first one's going to be an obtuse triangle. When you're looking at ADC, I'm going to do it in a different color. ADC is red. What do you notice in that one? All acute, or do you notice an obtuse, or do you notice a right?
Right.
There's a right angle. This one has the right angle right here. So they're going to show you pictures of things overlapping, and you have to find the right part. That one's a right triangle. Right in geometry doesn't mean right hand. It means 90 degrees. B, C, D. Here's B, C, D. Now you don't know what all these angles are yet. What's this angle right here? 80. 180 right there. This one's 150. Subtract from 180, that means 30 right here, right? So what's this angle going to be?
60.
60. So what kind of triangle is that green one?
Cute.
Acute. But you can't just assume that. You have to know that. Acute triangle. And for the bottom, this time they don't want obtuse, right, or acute. They want words like scalene, isosceles, or equilateral. They want you to talk about the side lengths. So let me highlight them for you again. G, I, J. There's a lot of markings there. Those markings mean that those sides match. So this one is 6.9 with no markings on it. This one has one mark, but this one has two of those same marks. Are any of those the same? No, we don't know what this mark means except that it matches this one. So that one's scaling. None of those sides match. Whatever this is, this one is two of those. That's twice as long. And this one is not equal to any of them. H-I-J. H-I-J. You can give that one 2 names. What 2 names can you give that one? We're only looking for side length measures. Isosceles and equilateral, that's right. It's got at least 2, and it happens to have 3 sides equal. It is also equiangular, but that doesn't fit the question they're asking us, so we won't answer that way. And the last one, GHI. How many sides do you see matching on that one? Sorry, GHJ. 2. 2 sides match right here and right here. So that one would be called what? Just isosceles, not both. This one's just isosceles. So know the difference between those.